So in this example, we want to map the semicircle of radius 1 to the upper half of the W plane. Okay, so we've actually already done an example where we mapped the unit disk in the Z plane to the upper half of the W plane, and that transformation was W equals I times 1 plus Z over 1 minus Z. Okay, so this transformation maps the whole unit disk to the upper half plane. Okay, so just to recall, it mapped Z equals minus 1. So let's just well, consider this mapping. So let's call this F1 of Z. So F1 of minus 1 gives you 0. F1 of 1 goes to infinity, and F of 0, F1 of 0 goes to I. So what we actually want to do is, to save us a bit of effort, what we're going to do is just see what this transformation does to this semicircle. So if I label this as what's happening with F1. Okay, so the line minus 1 to 0 to 1, those 3 points. So minus 1 gets mapped to 0. Uh, 0 gets mapped to I, and 1 gets mapped to infinity. Remember, infinity is the point at infinity, which you can think of as either infinity or I infinity or minus I infinity or anything times infinity. So effectively, we can think of this as this infinity, if we like, as the end of this line. This line will go to I infinity. Okay, so that basically means that from here to here, these 3 points get mapped to 0, I, and infinity, which is way up here. So that means this line here gets mapped to this line here. Another way of looking at it is that, well, if this is fairly easy to see, if Z is real, then you get a pure imaginary number out, so that sort of makes sense in that way as well. Okay, so this boundary here gets mapped to here. Then we've also got what happens to I. So I gets mapped to I times 1 plus I over 1 minus I, which is e to the something times, it's root 2 times e to the minus by 4 times I. This might not be the quickest way of doing it. Anyway, something is root 2 times e to the I pi by 4 divided by e to the minus I pi 4. And I've cancelled out the root 2's. So that gives me, this actually gives me minus 1 in the end. Okay. So F1 of I gets mapped to minus 1. I think we actually worked that one out before. So these 3 points, minus 1, I, 1, get mapped to the points 0, minus 1, and the point at infinity. Okay, so minus 1 gets to map to 0, and then I go around here, and I don't want the stuff to the left. At this point, I gets mapped to minus 1, so I don't want the stuff on the left. So I go along here, this is minus 1, and then I carry on to 1, which is the point at infinity, which is just like this. So that means that at the moment, f1, this transformation here will map the semicircle onto this region here. So the trick I'm going to now use is just to square this map. So what happens if I square this map? Then that means that any argument here, which is between pi by 2 and pi, well, pi by 2, when I square it, will turn into pi, argument pi, and pi, when I square it, will turn into 2 pi. So basically, if I then consider f1 squared, so the map, this thing squared, then basically what this semicircle is going to get mapped to, this line here will instead get mapped to here, and this thing here will instead get mapped to here. So finally, what I actually want is not the lower half plane, but the upper half plane. So I just multiply everything by minus 1. So my final answer is this thing squared times minus 1. So I guess in the end that it's going to be 1 plus z over 1 minus z. The I squared gives minus 1, and then I'm timesing minus 1, so I just get that as my final answer.